We have tried to understand philosophy of dynamic programming by means of two problems which we have taken in earlier classes. The first one was shortest root problem, and the next one we have seen in earlier class, was the capital budgeting problem, or simply budgeting problem. Right? In this class, we'll be seeing cargo loading problem or knapsack problem. This category of problem, we have to load any number of three items A, B, and C in a vessel or a cargo or a knapsack. Okay, the capacity of the vessel is 4 tons, and the utility of the vessel is to be maximized. Utility of the knapsack or utility of the cargo is to be maximized. Okay. So here the details of the item are given. There are three items A, B, C. The weight per unit in tons is given to you respectively 2, 3, and 1. And utility per unit or profit per unit or something to be maximized is given to you here. That is 26, 43, and 40 utility value per item A, B, and C respectively. Now, we will be breaking this problem into three stages. That is the first requirement to handle the problem by dynamic programming. Okay. Now, in earlier problems, we have seen that we have taken the forward scan. It is possible to see the problem in a reverse scan. Okay, so this problem intentionally will be taking in a reverse scan. So my stage one, which otherwise I would have taken just to load the item A, then B along with it, that is stage 2, and then C along with B and A, that is the stage 3. But I will be doing it reverse way. Okay, just to make you learn on the reverse recursion approach. Okay, so this stage, which normally would have been third stage, now is stage 1 for me. This is stage 2, and this is stage 3. Okay, so stage 1 is what you may do the analysis in forward way by taking item A and then item A as stage 1 item, then B, and then C. But just to make you understand the other way, okay, I am taking it reverse. First C, then A, then B, and then A. So what are the stages? What are the states? States are assumed limit of the constraint. All right. So I may assume that I don't have any capacity in the vessel. I have 1 ton capacity in the vessel, 2 ton, 3 ton, and 4 ton capacity in the vessel. There is no point in taking the capacity of vessel as zero point 0.5 or zero point 0.6 or zero point 0.9. Okay, because I don't have associated return for those intermediate values. Okay, there is one more consideration to be taken into mind while deciding the state's value. Okay, when we go to subsequent stage, then I'll be requiring return for remaining value of state, and that remaining value must be available in previous stages. All right. So alternatives. So here are the alternatives. What are the alternatives? The alternatives you will have to find out from the problem. Now, my first alternative could be I won't be loading any item of C, zero items of C. And if I do that, how much capacity of the vessel I will be utilizing? I will be needing 0 tons. And what will be the utility value? Utility value will also be 0. Then second alternative, I may be loading 1 unit of the 1 unit of item C, and if I do that, weight of the vessel which I'll be requiring or I'll be consuming 1 ton weight of the vessel, and the utility value will be 14. Then likewise, third alternative, I may be loading 2 items of C, and if I do that, then the weight consumed will be 2 tons and the utility value will be 28. Okay, utility value multiplies if I load multiple units of product C, okay, or B or A. Then fourth, I may be loading 3 units of product C, item C. The weight, the cargo capacity needed will be 3 tons, and the utility value will be 42. Okay, 14 3 is 42. And fifth alternative, I will be loading I will be loading 4 units of product C, that will require 4 tons capacity of the vessel, and the utility value I'll be earning will be 56. 14 4 56. And sixth alternative won't be there. Why? Because sixth alternative, if I think of loading 5 units of item C, then what may happen, the capacity required of the cargo will be 5 tons, and I don't have 5 tons capacity in the vessel or cargo. Okay, here R star optimal return, and here returns. Okay, now once this much is done, you know what is to be done next. Okay, if I assume that I have 0 ton capacity in the vessel, I can use this alternative, but I cannot use these alternatives. Okay, because these alternatives will require you to have respectively 1 ton, 2 ton, 3 ton, 4 ton capacity. In You will have to assume that you have that much of capacity. So this third value is the return. Return value you keep at the end so that you can directly write it in respective column. So 0, for choosing this alternative, the the utility value, return value will be 0 all throughout in that column. Okay, if I am able to choose this column, this alternative, then the utility value will be 14. So if I have 0 ton capacity in the vessel, if I assume there is 0 ton capacity in the vessel, I won't be able to use this alternative, this alternative, this alternative, this alternative, because they require 1 ton, 2 ton, 3 ton, 4 ton capacity in the vessel, which I am assuming that I don't have. Now, if I assume that I have 1 ton capacity in the vessel, will I be able to use this second alternative? Yes, I'll be, and in that case, the return value will be 14. Utility value will be 14. Right, all throughout, whatever be the capacity we assume. Okay, as long as you are able to choose this alternative, return will be 14. Okay, then if you are able to use this alternative, which you are not until you have 2 ton capacity assumption for the vessel. So for 0 and 1 there will be dash, and for 2 ton the return value will be 28 and 28 and 28. Okay, again here, this alternative, fourth alternative, you won't be able to use until you assume that you have 3 ton capacity in the vessel, and if that is, then 42 will be the utility value. And likewise here, see here, 56 will be the utility value, and now you compile optimal return. So if your state is 0, that is, you assume that you have 0 ton capacity in the vessel, optimal return will be 0. If you have 1 ton capacity, if you assume you have 1 ton capacity, the return will be 14, then 28, then 42 and 56, because you want to maximize the return. Okay, so here is end of first stage. Now go on to second stage, stage 2. Okay, then in stage 2 you will be thinking of loading item B as well. Okay, and if some capacity is remaining in the vessel, then you will be loading C item as well. So this stage is labeled as B plus C, but it is essential that you must be writing B first, because your primary consideration, your alternative will be for B. And by choosing certain alternative, you feel that there is some capacity left in the vessel that you will be optimally utilizing for C. Okay, so alternatives and states. What are the states? Again, those will be, I may be assuming that I have 0 ton, 1 ton, 2 ton, 3 ton, 4 ton capacity available in the vessel. Okay, that constant value 4, I am breaking into various values. This I don't do in simplex method. Whatever is the constant on right hand side, I have to keep it constant. But here I am variabilizing it. Okay, I am taking different values for it. So my first alternative, now again I may not be loading any item of B, and therefore if I don't do that, if I don't load any item of B, then the capacity of the vessel required will be 0 and utility also will be 0. If I load, no, this is for C, not B. No, this is for B. Okay, then I'll be loading 1 unit of B, and if I load 1 unit of B, 3 tons capacity of the cargo or vessel will be required, and what will be the utility value? 43. Okay, can I load 2 units of B? No, I cannot, because uh, it will require 6 ton capacity in the vessel. Okay, and I have just 4 tons, so I cannot uh, take third alternative. Here alternatives you have to generate. In earlier problem, those were much evident, much visible from the problem itself. But here, when you think of B, what can be done with B as far as the vessel is concerned? You may be loading one item, 0 item. This you will have to think. That may not be given in the problem. Okay. If you have a 0 ton capacity, you assume that you have 0 ton capacity, the return will be 0. First component of the return will be 0. Second component will you will have to think, because you have not loaded any item of B, all the space is available for loading C. Okay, so when you assume that you have 0 ton capacity and B hasn't consumed any capacity, so 0 ton still is available, which can be optimally utilized for raising the utility value to 0. Then 1 ton capacity of the vessel will still be remaining, which will raise the utility value to 14, because I will be loading 1 unit of item C in that vessel. You assume that you have 2 ton capacity available, and that still will be 2 ton, because you have not loaded any item of B. Alright. So 2 ton is available, 2 ton is optimally utilized, and that gives you the return value 28, and likewise 42, and likewise 56. Now, this alternative you cannot use until you have 3-ton capacity in your cargo. So, this alternative will not be available if you assume that you simply have 2 tons capacity. When you assume that you have 3-ton capacity, return will be 43, and 4-ton also return will be 43 because you have chosen second alternative. Okay, now remaining capacity after consuming the capacity of vessel for loading B, there will be some capacity remaining. Let's find out that. Okay, you assumed you have 3-ton capacity and you have consumed 3 tons. You have 0-ton available and 3 minus 3 0, and for 0-ton optimal return which you can get is 0 from previous stage. And if you assume that you have 4-ton capacity, 1-ton will be remaining for which the optimal return is 14. Alright. Now, you remember that for whatever is the capacity remaining, you must have the return available for that remaining value of state in the previous stage. Okay. Through that point of view, you should you should take the state values. Okay. So 4 minus 1, for 1, the return is available and that is 14. And the optimal returns now, if I load B and C together, if I assume I have 0-ton capacity, 0 will be the optimal return. If I assume 1-ton capacity, 14 optimal return. For 2-ton, 28. For 3 tons, it is 43, and for 4-ton this is 56 and this is 57. So 57 is the optimal return. All right, then coming on to going to stage 3. All right, stage 3. Now what, I will be concerned with loading item A. B and C I have already analyzed. Okay, A, and whatever remains will be optimally utilized for loading B and C together, which we have considered in the previous stage. B and C combination together. Okay, then my states are 0, 1, 2, 3, 4. Okay, then alternatives. Posted now, the weight per unit of item A is 2. So you will have to keep that in mind while you take the alternative. Okay, so first thing here, okay, this is the number of units of item C, second is weight, and third is the return. Return must be written, should be the last value in the alternative description. Okay, and this is your discretion what to write first and what to write next, but it is preferred that the written value should be available to you at the end of the alternative description, right? So that you don't have to search for it, right? So your first alternative is don't load any item up A. So weight consumed will be 0 and utility will also be 0. Second alternative, load one item, weight is 2 and utility is 26. That's given in the problem. Third alternative, load two items. Weight consumed will be 4, or weight required, capacity required will be 4, and the um, the return value, utility value will be 52. Okay, because two items are getting loaded, 26 into 2 is 52, right? Now, this first alternative you can use for all the states. All right. So here you see my first term will be written from taken from here. It is all 0, right? Plus 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 plus. Okay, and this capacity will be remaining will be available to me, which I can use for loading items B and C together and increasing the utility value. So for 0 unit capacity, 0 ton capacity remaining, I have the optimal return from previous stage 0, then optimal return here from previous stage 14, then 28, then 43, and then 57. Okay, in this problem, in the explanation of this problem, I am not detailing the things to the extent I have detailed the things in previous classes. Okay, so if you are seeing this class without seeing earlier classes, then you might face little issue. So it is advised that you will be seeing earlier two classes first and then this one. Now, this alternative is not available to you until you assume that you have 2 ton capacity available, and when you have 2 ton capacity available, then the first component of the return will be 26 and the next component will come from previous stage for the remaining value of state after consuming after consuming certain amount of state for alternative. So here from I assume that I have 2 ton capacity and I have consumed 2 tons. So what is available to me? 0 ton. 2 minus 2, 0 ton, and the optimal return will come for that, and that is for 0 ton, it is 0. Alright. Then 3 minus 2, 1 ton is remaining, and for that 1 ton, optimal return is 14. And 4 minus 2, 2 ton is remaining, and for that 2 ton optimal return from previous stage is 28. This alternative you cannot use until you have 4 tons capacity available in your vessel. So when 4 ton capacity is available, return will be 52 and second component will be 0, because 0 ton capacity will be left in your cargo or vessel R star. Optimal return now, maximum values in each of the row for each of the state. 0 here, 14 here, then 28 here, then this is 43 and this is 40. Okay, 43 is maximum, and this is 57, this is 54, and this is 52. 57 is maximum. Okay, so the utility value of the cargo or the vessel will be maximum 57. Now, how to load the vessel? Okay, this 57, now backtracking. 57, this 57 is because of this. So what does it imply? It implies that you should load no unit. Okay, item, here I'll be writing the description of my solution item, then whatever are written values here that you should write here: item, weight, and utility. So as far as item A is concerned, you have to write this description. You won't be here I have the number 0 units, weight is 0, and utility is 0. Now you had 4 ton capacity of your vessel. So 4 ton, because you haven't loaded any unit of A, weight consumed is 0 and you are still left with 4 ton. Okay, so that 4 ton you check in the previous stage. So here it is. For 4 tons, the best return is 57, and this 57 is because of this. Okay, and this for this you check the alternative. And what is that alternative value? You for B item, that alternative is for B. Okay, how many items you are loading? One. The weight is 3 and utility is 43. Now out of 4 tons, you have consumed 3 tons. Earlier you had 4 ton capacity in the vessel, out of which you have consumed 0, and therefore you still have 4 ton capacity. Now from 4 tons you have consumed 3. Okay, you have 1 ton capacity left for the third item, that is C. I am going in reverse way. Where C was the first item considered. So C. Now for 1 ton, we just check for 1 ton, the optimal return is 14. Okay, so your optimal return is 14, and this 14 is because of this, and this is because of this alternative, wherein you will be loading 1 unit of item C, and by doing that you will be requiring 1 ton capacity of the vessel, and the utility is 14. Okay, so here if you sum it again, weight is 4 ton and the utility is 57, right? So this is the way we naturally also do the computations. Whenever such problem is asked to us, such simple problems are asked to us, we process this problem in our brain this way only. Okay, the processing is so fast that we don't know that we have processed the problem in this fashion. Okay. The frequency of our brain processing is very high. That's why we don't come to know the way by which we processed it. So we will stop here, and we'll be taking one more problem, and that is in the next lecture.